Hi viewers, this is Sri Ramulu. So it is a part 2. So the questions here from 11 to 20 solved paper IIT-JAM 2019 solved paper, and here each question carries 2 marks only. So what are those questions? 11th question. Already I have uploaded 1 to 10 questions. Now these are the 11 to 20 questions. First, a thin lens of refractive index 3/2 is kept inside a liquid refractive index 4/3. If the focal length of the lens is in air is 10 centimeter, then its focal length inside the liquid. Okay, so focal length in air is given and refractance of a liquid and glass also given. Lens means glass. Okay, so refractance of the glass, that is a lens, is 3/2, and a liquid refractive index is this much. Air refractive index is 1. So we know air refractive index. Okay, by lens maker's formula. So general lens maker's formula is what you know, 1 by f is equals to mu 2 by mu 1 minus 1 into 1 by r1 minus 1 by r2. It is actual formula. Okay, 1 by f is equals to mu 2 by mu 1 minus 1 by r1 minus 1 by r2. It is a lens maker's actually formula. Okay, so mu 2 is the refractance of the second medium by refractance of the first medium. So you must write the below first medium and above second medium. So below first medium and above second medium. Okay, so in by lens, so when you keep the lens in air, the rays comes from the air medium to denser medium, that is a lenser medium. So that is why air medium is first medium and glass medium is second medium. So first medium by second medium by first medium. Okay, and the values are given above. Substitute those values, these values. So Ng it is, and here, and this value is here. Then what you get? Here you can get only 3/2 only. Sorry, 3/2 can get, right? This is 3/2, and f value is how much here? F value is this much. F is equals to 10 also above given. So when it is in air, so substitute here and then simplify these two things and you can get this one. Okay, so after simplification, so let it is equation number 1. Next, so now the focal length of now focal length in air, not in air, it is in liquid. It is focal length in liquid. Okay, focal length in liquid we have to calculate, not in air. So that is what first medium here, second medium here. First medium is liquid. So here what we are doing, let it is a vessel containing the water, and inside it we have to keep a lens, and let the light is coming from air medium. So first it has to enter into the water and later glass. So here water medium is the first medium and glass medium is second medium. So that is why here what? Here it is first medium, it is second medium. Okay, mu 2 by mu 1. And substitute the values are also given above this one. And just now we have calculated its value as 1 by f, 1 by 5. Substitute these values here and simplify them. Okay, after simplification you can get 9 by 8 minus 1 by 5. So it can be written as 1 by 8 into 1 by 5, and finally we can write 1 by 40. So fa is how much? It is 40. So it is not fa, it is fl. You have to write fl. Why? Focal length in liquid. Okay, so focal length in liquid is 40 centimeter. Okay, focal length in air is how much? 10 centimeter already is given. And the next question, eigenvalues of the vector of the matrix 3 I 0 minus I 3 0 0 0 6. So what are the values? So option is given as A. Matrix, it is given matrix, but for eigenvalues formula is what? A minus lambda into I, where A is a given matrix, lambda is eigenvalue, I is a identity matrix. And see here, so A here substituted minus lambda, and identity matrix is this one. Okay, 3 values are substituted here. And now multiply lambda inside, then where you get here, here and here only, and subtraction 3 minus lambda. Okay, 3 minus lambda. Next I minus 0 is I only. Next 0 minus 0 0. Next minus I minus 0 minus I. 3 minus lambda 3 minus lambda. 0 minus 0 0. Okay, 0 minus 0 0, 0 minus 0 0. 6 minus lambda is 6 minus lambda. Okay, now finally it is converted into single matrix. So let me take its determinant. Okay, single matrix determinants. Assume, so 3 this into, so assume this row, this column and row not appearing, then let it is A, B, C and D. AD minus BC, take here AD minus BC. Okay, so AD minus formula is taken. You know how to solve the matrix form, so by using this here you can get like this. Okay, and from this what you have to take, so multiply it inside, it become like this. Okay, and finally you can get this one. Take out the common factor which are appearing here. So 6 minus lambda is appearing, so take outside it is, so we can write it is like this, 6 minus lambda, and A minus B whole square form is there, so expand it. So before expansion what you have to write, so this product and this product is 0, means this product is 0 and this product also 0, so separated like this. So it is written here and this is written here. So 6, its answer is this one only. And what about its answer? So it is A minus B whole square form is there, just expand it, A square plus B square minus 2AB form is there, minus 1 as is equals to 0. Okay, so from this we can write it is like this. And so separate this one, minus 6 can be written as 4 lambda minus 2 lambda, and if you multiply them you can get this, and if you add them you can get this. Okay, so like this we have separated, and take here common lambda and here common 2, then so you can get like this, and here common factor is lambda minus 4, so take it is outside, and see their product 0 means this and this also 0, so this 0 and this 0, and from this you can get lambda 2 and lambda 4, and 6 already we got above it. Okay, so where we got here 6, so like this 2 4 6 is the answer. So where is that 2 4 6? 2 4 6 is here, so our option is A. And next question number 13. For a quantum particle confined inside a cubic box of side L, and a ground state energy is given as E0, given by E0, the energy of the first excited state is, okay, so there is a quantum particle, right, and it is inside a box whose side length is L. Okay, then what you have to, and its ground energy is also given, but what we have to calculate, we have to calculate here its first excited state. Okay, so first excited state, so let it is in 3D body particles. So 3D body particles, what we can write, so first ground state is 1 1 1 we have to write. Okay, so here see energy of the quantum particle confined in a box of side length side L is, it is actual formula. Okay, E nx comma ny comma nz is equals to h square by 8 m L square nx square plus ny square plus nz square. So for ground state it is a value, ground state value means nx ny nz value must be 1. Okay, so it is 1, and its answer is we got like this. Okay, next first excited state. So first excited state means suppose there are 3 particles are there, 3 particles. Okay, so it is nx ny nz, so one particle here, one particle, already we kept all particles in first state only, and the next time what we can do, we can keep 2 particle here and 1 particle is here, so 1 1 2 like this, 1 1 2 or 1 2 1 or 1 1 2, so 2 1 1 are, so like this, in any manner we can arrange. So different forms we can get like this. Among them take any one value, any one as you wish. So here I have taken this one and substituted in this formula, nx as 2, ny as 1, nz as 1. So substituted here I got this one, and it is like this. And see, this is also can be written as like this. So see, it is 2 6 h square by 8 m l square. So it can be written as 6 can be written as 2 into 3 h square by 8 m l square. So what is this? It is E naught, right? So E naught can be written as E1. E1 is equals to 2 into E naught. So E1 is equals to 2 into E naught. So where is it? 2 into E naught. It is answer A. Now, a small spherical ball having charge Q, mass M, is tied to a thin massless non-conducting string of length L. Okay, the other ends of string is fixed to an infinitely extended thin non-conducting sheet, without uniform surface, with uniform surface charge densities sigma. Under equilibrium, the string makes angle 45 degree with the sheet as shown in figure. Then sigma is given by. So what is here? A small spherical ball. So small spherical ball is having the charge. So on it charges are, and its mass is m is given, and it is tied to what? Tied to a thin massless non-conducting string of length L. So it is connected to a non-string. It is a length string and its length is L. Okay, so side diagram is given. It is bob or spherical ball. Next, the other end. So another end is of the string is fixed to infinitely extended thin non-conducting sheet. So it is another end is connected to the thin sheet, and a sheet its uniform charge density is how much? Sigma. Under the equilibrium, the string makes an angle 45 degree. So under equilibrium condition, how much it is making angle? So 45 degree with the sheet only as shown in figure. Then what you have to calculate? Sigma. Here we have to calculate. See the diagram once again. See, it is a bob having charge, and it is connected to the what? A sheet of infinite length, and it is making how much? 45 degree. Okay. Now, so electric field due to infinite non-conducting sheet. So already we know it is electric field due to infinite non-conducting sheet is E is equals to sigma by 2 epsilon naught. Okay. Electric force on a point charge Q. So generally we know the formula force is equals to charge into electric field, right? So take this value and substitute here. Okay, we got the force as what? Q sigma by 2 epsilon naught, and a weight on the bob, weight will act downward direction. That is, a weight is written as Fg, gravitational force, that is mg. Okay, as the particle is in equilibrium. Okay, when the particle is in equilibrium, then see here. Now see the diagram. Not it is appearing clearly. It is a bob. Okay, and this side is tension is T. So this tension can be divided into two parts, resolved into two parts. This side is making this angle is T, means it is angle of according to angle of equivalence. This side also angle, same angle, that is a 45 degree. So this side making angle side is cos theta, and theta value is 45. So T cos 45. This side not making means T sin 45. And weight acts downside. So its weight is how much? Mg. Okay, so its weight is mg. But when the balance, when this value is equal to this and this value is equal to this, then only this bob is in balancing condition. Now see. Right, see side diagram also, and this mg is equals to T into cos 45, mg is equals to T cos 45, right? And next this f is equals to what? It is at the last end is, see, F is equals to QE, it is QE is equals to T sin 45, QE is equals to T sin 45. Okay, so like this we got, and divide these two equations. Okay, this equation by this equation. Okay, so T sin 45 by T cos 45 is equals to QE by mg, isn't it? Okay, now side come to the box. So it is a T cancelled, sin 45 cos 45 becomes tan 45, tan 45, this value is written as it is. Okay, but already we know E value is written as, here in the place of E, what, sigma by 2 epsilon naught, sigma by 2 epsilon naught is substituted. Okay, why? Because we have to calculate sigma value only. So tan 45 answer is, we know, that is 1. So here Q sigma E by this 2 epsilon naught comes downside, so it is like this. Now bring except sigma, bring all these quantities this side, that is the answer of what, sigma. Sigma is equals to epsilon naught mg by Q. So where is 2 epsilon naught mg? 2 epsilon naught mg by Q is C. Option is C. Okay, so like this you have to calculate. And now next, 15th question. Consider the normal incidence of a plane electromagnetic wave with electric field given by E is equals to E naught e power I k1 z minus omega t into x cap over a interface z is equals to 0, separating two media, that is two media, wave velocity v1 and v2, and here condition is v2 greater than v1, and wave vector is k1 k2, wave vectors k1 k2 respectively. As shown in figure, the magnetic field vector of the reflected wave is so magnetic field vector we have to calculate here, magnetic field vector of reflected wave only. Okay, so see the diagram also given in the question. There are the two medias are there, medium 1, medium 2. This side velocity and vectors are 1 2, velocity and vectors are, here 1 1, here 2 2, this side. Okay, it is a sheet and electromagnetic waves are coming. Okay, reflect. Now see, in which direction? See, the electromagnetic waves are coming along the z direction. See, z direction, y direction, it is x direction, along the z direction. So given electromagnetic wave with electric field is E is equals to E naught e power of I k1 z minus omega t. So k1 z means in the first medium, x cap. Electric field equation for reflected means reverse direction. In reverse direction means opposite to the z. So opposite to the z means minus z only. In the place of plus z, minus z only you have to write. But k value is same. Why? In the same medium it is coming. Okay. And see here, minus is written. It is a plus, it is a minus, indicates reflection. So ER is reflection, reflected wave. And this equation is written like this only. Here minus means reflected wave only. As we know, magnetic field, there is a relation between the magnetic field and electric field, is, that is what you know, magnetic field is equals to electric field by velocity. Okay, so reflected wave here, if it is reflected wave, then it is also reflected wave for magnetic field. And the direction of BR is equals to K cross E R by V1. Okay, so why it is coming in the same medium? So is this medium along the z direction, along z direction which vector present? K vector present, unit vector K. Okay, so that is why that is written as K cross E1, ER by V1. Okay friends, so K, so ER value is what? It is substituted here by V1. Okay, now these two take outside with a minus, yes, and K cross here, what you have? K cross here, K cross into X, K cap cross X cap. What is K cross X is Y. Okay, so that is why here Y is written. Okay, so this is a magnetic field in reflected wave. So magnetic field in reflected wave is minus E naught by V1, where you have into Y cap. minus E naught into y cap. So this is answer. Okay friends. Next, 16th question. The output of the following logic circuit can be simplified to. Okay, so it is output. So here inputs are there, x, y, z inputs are there. So by using that, what we have to calculate? We have to calculate its output. Okay. Now see here, circuit diagram also given. It is which gate? AND gate, OR gate, AND gate, AND gate, OR gate. So x come outside. So here in the below diagram is given, see, x and y if inputs, AND gate it simply multiplies. Okay, AND gate multiplies, OR gate adds. So multiplied. So OR gate is, see, to the OR gate which are connected, z and this one only. So y. So y output has come, and this is this output is input to the this one, and see, and here so it is connected, here not connected, here not connected, so directly it connected to x. So that is why the AND gate again x, these two gets multiplied. Why they are coming through AND gate? Okay, so this is one of the input to this one, and come to here. See, it is connected to this one, so it is input of this gate also. And next one more input is y. So it is an AND gate, so that is why these two again multiplied here, and it is input to this one, and not only, and also this is also input. So finally what it can do, it add. So this plus this plus this, so like this it is added, that is written here. And we have to simplify it by using loss. Here xy plus x into y plus z plus y into y plus z. So that is output just now we got. Now multiply this inside, and it is also inside. Here xy, and here xz, next yy, yz. So you know yy is answer y only, not y square, right? So that is why, and side also given, see here, y into y, y only. Okay, y plus yz is y only. Okay, y where? Y plus yz. Okay, so y into y, y only, and so here y has written, and it is repeated. Next, and here next is xz is there, xz copied. Here xy becomes 2xy cannot be written just to xy only, so by replacing this, 1 is written. Now so its answer is this one only. And now y plus yz is y plus yz is y only. Okay, and next xy plus xz. So xy plus xz is written as it is, and the place of this is y. And now see here these two things. So these two things written one side, and it is written this side. So its answer is y according to this. So final answer is, and it is copied. Final answer is what? Y plus xz. So where is y plus xz? Next, a red star having radius rr at a temperature Tr, and a white star having a radius Rw at a temperature Tw, radius same total power if these stars radiate as a perfect black bodies, then what is the equation? Hot star emits white light, cool star emit red light. So red light means low temperature, white light means high temperature. So condition is Tw is greater than Tr, white light temperature higher than the red light temperature. But by Stephen's law, power radiated is power is equals to A sigma T power of 4. So A is area. So area is means pi r square. So that is area is directly proportional to r square. A is equals to pi r square actually. So by using these two things, we can write A is directly proportional to r square. Next, hence Here power in the place of A is substitute. Power is directly proportional to R square into T is power 4. But powers are equal in the above equation. It is given condition. When the power radiates equal powers, then P white light is equals to P red light power, and substitute the values. Just now we know TW temperature is higher, white light temperature higher than the red light temperature. Then what happens? So it is high. TW is high. It is high. Okay, it is high means, and their product is equals to this means it is high. Okay, so RR is greater than the RW. So RR is greater than the RW, where RR greater than RW and TW greater. It is RR greater, where RR greater here and here also. RR greater and it is C. So condition answer is C. The mass per unit length of the rod, unit length of the rod. So length is 2 meter, where is as rho is equals to 3x. The moment of inertia of the rod about perpendicular axis passing through the tip of the rod. Tip means border, just border of. It's a final point. Okay. So here rho is given. It is not constant. It is a variable. It is given as 3x. So solution. Length is 2 meter is given in the question. Consider the element of length dx at a distance x from the one end. So here one small length is taken at a distance x from the one end. Let its mass. So whose mass is this small length mass is dm. Then moment of inertia. Moment of inertia is what? I is equals to mass into distance square. So mass is a small mass and the distance is x is taken, x square. So given that rho is equals to what? 3x. Okay, so in given rho is 3x. But mass formula is what? Mass is equals to, rho formula is what? Length by mass. Okay, so rho formula is length by mass. Is it actually mass? Rho is what? Mass per unit length. Rho is what? Mass per unit length. Length is small, dx is taken. Write this. So from this what we can write? Mass is equals to rho into dx. So mass into rho dx. Rho value just now above given as how much? 3x. Substitute 3x. dm value we got, and take this value and substitute in di. Okay, and integrate that after its substitution. Integrate where to where? 0 to L. Okay, so what do you get? 0 to L. So here I is equals to 3 into x power of 4 by 4. So first substitute 2 value and next substitute 0 value. So what do you get? This is answer. And 4 1s are 4 4s are 3 4s are 12. So answer is 12 kg per meter. So 12 is option is B. Next question. For a forward biased PN junction diode, which one of the following energy band diagram is correct? Okay, so energy band diagram which is correct, that is we have to see. So energy band diagram, what are the given in the band diagram? This side energy, this side valence band, above conduction band. So that means as you move upside, energy increases. Solution. When a PN junction is forward biased, forward bias, the electron in N type which have been elevated to the conduction band, okay, which have been elevated to conduction band and which have been diffused themselves across the junction at higher energy than holes in P type material. Okay, so here in PN junction diode in forward bias, electrons, what happens? Electrons are from N type have been elevated. They are moves towards what? Conduction band. Okay, these electrons readily combine with the holes. Which electron? Where the electron were diffused to junction only. So they are ready to combine with holes, making possible continuous forward current junction through the current. So that means the answer is so here only you have. Okay, so here the conduction band very near and here it is valency band. As energy we move upside, so more electron here present and less electron here present. So answer is A. The amount of work to increase the speed of an electron from c by 3 to 2c by 3. C value is this, and rest mass of electron is 0.511 million electron volts. Rest mass of energy of electron is given as, rest mass means m naught c square, is according to Einstein equation mc square. For rest mass m naught c square. Okay, n naught is a mass of electron, so rest mass is also given here. Okay, that is this much. Speed is given by work energy theorem. Work done is equals to change in kinetic energy. Work done is equals to change in kinetic energy. Okay, moving masses of electron at a speed. So first speed is v1, second speed is v2. Why? Because in the question is given c, it is v1 and this is v2. Okay, and moving electron speeds, and these are the masses m1 m2. Then k is equals to, so k is what? It is kinetic energy. Kinetic energy is m change in mass into c square. According to Einstein one, E is equals to what? mc square. Let this energy is k1. So okay, this mass is change in mass. So which mass? It is when it is in motion, and rest mass, motion mass minus rest mass. Why rest mass is lesser than less? Always motion mass is higher. So then we get energy, that is k1. Next to, for because of m2 it is k2. Take their difference. Here we need difference. After taking difference, this one. But when the body is moving, its mass changes. Change in mass can be obtained by the equation m1 is equals to m naught by under root of 1 minus v square by c square. But 1 means v1 square by c square. For 2, v2 square by c square. Okay, and substitute these values. Okay, substitute these values m1 and m2 in the equation 2. Then what you get? You can get this one. Okay, like so here equation 2 substituted, m naught taken outside and c square also. So its value we know already, above is given, it is like this. And v1 here v1 it is v2. Okay, here v1 v2 also given. Substitute them and simplify it. So its value is here and here, it is simplified. So after simplification, what you get? This much. So finally work done is what? K2 minus K1. So it is 143.3 kilovolts. So answer 143.3 kilovolts. 143 point, where is 143? It is 143.3 means it is somewhat mistaken. 143.3 it is. Okay. So okay friends, this is a IIT second video. So please watch this video till the end. Okay friends, thank you.